Hola.
All right. Well, let's start by talking about assignment 4. Because there were some problems I did not anticipate. Okay. Seems like a couple people have started their own meeting. I'm going to see if I can bring them over here. Okay. 1 second. All right, I'll be right back.
I hope you all had a great weekend.
Yes, I did have a fairly good weekend. Completed that test for this class.
Okay. I hear somebody say they were already done with the exam.
Yeah, I did the exam.
Okay, cool.
Wasn't it due today before class?
No, the end of this week.
Oh.
Oh.
You thought that it was due today, dude.
Yeah, I thought it was due today too.
Me too.
No way.
The longest one's due at the end of the week.
The exam is due at the end of week 5.
Oh my gosh.
Oh my
Can you
gosh.
resubmit it? Is that open to be resubmit?
Yeah, you can resubmit. That's fine.
Okay.
You got another week.
Nice.
Did anybody do question 6?
Yes, I did. I made my question 4 answer so complicated that the solution to number 6 was contained in number 4, so I only had to copy paste.
All right, so what we're going to do is next Monday, I'm going to go through the exam live and just kind of do it because it'll be due, before class next Monday. And so you'll get to see how I approach answering all those questions. All right, but assignment 4. Did everyone see the exchanges that were happening on our Teams channel about some of the weird stuff happening?
Yep.
Okay. So the first thing, when R updated to version 4, it changed some of the default behavior of the read.table function, okay, which is a good thing, honestly, but it used to be, and still is on my computer, that the default for read.table, which includes read.csv, was strings as factors equals true. Now it's false. So that's one big thing. And then Lacey found that the plot function wasn't taking a character vector as a valid x-axis or to color by. It wanted a factor. Okay, so that kind of came up and broke the assignment. So I'll take that into account as I'm grading them, but I will try to remember that, and I'll definitely change it for next semester. What didn't occur to me, because I'm, I guess, an idiot or just not thinking things through, was that when I had you all download and install R at the very beginning of this class, you'd be getting the newest version, and then I forgot that changes were made. Okay. So any questions about assignment 4 aside from that? Aside from it breaking, yeah.
Yes, like there were columns that were not there. They were missing totally. Like every single header was there, but there were columns that were just not there, and it scooched everything over to the left, so they were all under the wrong heading. And I had random stuff like that happening.
All right, let me open this up. So it was the land data states file, right?
Yeah.
Let me share my screen. Okay, I'm gonna go open data course Zon project. Control.
Actually, I
Oh,
think it might have been something else.
okay. Assignments. Assignment 4. So we're working through this land data states. And then basically your assignment was just to answer these questions. Okay. And this question obviously is broken. I need to make it backwards now. Okay, give summary stats for only the home value, comma. Okay, so we are just working with land data states. So I'm gonna do Control-Shift-N to start a new R script.
I had trouble with the part at the very end where it asks you to do a couple of things. We had to open one called It's Mapping, and I had a pretty tough time with that one.
Yeah, land data states should read in pretty easily. So let me see here.
Yeah, that one did.
DF read.csv data land data states.csv. I'm going to say strings as factors equals false on my computer because I've got an older version of R. That one looks good. Names, df. Yep, so that one looks good. The ITS mapping one though, df2 read.csv data ITS mapping.csv names of df2. Whoa. Okay. So I'm deliberately trying to mess with you. Read.csv did not work. How come?
Sorry, is this the assignment 4 one?
Yeah.
This is the tab separated values. So it'd be read.table, right? Sep equals
Yeah.
tab.
Yes. But wait a second. It very clearly says ITS mapping.csv.
It's a lie.
It is a lie. It is. File extensions don't actually mean anything to computers. If you're used to Windows, they've convinced you that file extensions are important because that's how Windows interprets things. But that's just, they've set a bunch of like little shortcuts that these files must be opened with these programs. CSV can be a lie. So when this doesn't work, I look here at my names and I see, oh, it's all one big name. What went wrong? I'm going to open my terminal. Make this a bit bigger. CD desktop. I go to Git repositories, data course, data. I look around. There's ITS mapping.csv. Head ITS mapping.csv. Huh. Not a comma to be found. Okay. So I lied to you with that file extension. Okay. I promise this is going to happen to you all the time doing any kind of data analysis. Things will be saved as .tsv and they'll actually be separated by a comma, or .csv and be separated by tabs. I've had instances where, let's see here, head.csv, I'm going to say search for tabs, replace with that. I've had things be separated by a little tilde before in data sets. So you need to inspect your data. Okay, if it's not working, go straight to the data source, take a look at it, because it absolutely can lie to you. So I can do read CSV and say sep equals \t for tab, and that worked. Or I could say read read.table, which uses tab as its default. Okay. So that was the trick there for the ITS mapping. It says CSV, but it's actually separated by tab. And I believe I even laughed at you in the document. Let me see. Pull up assignment 4 again.
I think my mistake might have been opening it up in Excel, and I think all the tabs became underscores and crap like that.
We're going to break you of this Excel habit this semester. I promise. We're easing into it gradually. I don't want to denigrate Excel. It's really good at what it's good for. But for data analysis, it is the devil itself. It destroys your data. They add formatting, they change things. If you have dates, they'll change them into their weird Excel numeric format and make it unrecoverable. It's really quite terrible. Okay. So don't open anything in Excel if you can avoid it. Okay. Yeah, here I say good luck with that. Okay, for the ITS mapping. All right. So hopefully you answered those questions and did this business down here.
I have a question real quick.
Yeah.
Just about that, since you did. So I actually did it differently. I used delim, and it still gave me a table that like separated it. But what is the difference then for delim instead?
Question mark read.delim. The difference is that tab is the default for read.delim, and read.csv is just a shorthand way of saying read.delim, the separator equals comma. Here you can see that the separator is already equal to tab in read.delim.
Oh, okay.
Yeah. So when you look at a help file, it's showing you what the defaults are. It's saying that header is by default set to false, but you could change it to true if you wanted. The sep is a tab. You can change it to the decimal is a dot instead of a comma. Okay. So it's showing you all the defaults. Read.csv, the separator is by default set to a comma.
And is a symbol for a new line like /n or something?
Mm-hmm. Yep.
I have a question, Dr. Zahn.
Yes.
So on the read.table, it says sep equals quote, quote, like an empty quote. But on the delim, it says that sep equals quote
Tab
/t. That would be tab, right?
Mm-hmm.
So is read.table, what is the default sep? It's not tab, is it?
It's nothing. This is a shorthand way of them saying that it's going to search for white space.
Okay.
Yeah.
So tab would.
It basically work. Tab works. Yeah.
Okay.
Tab
but it
works.
might look for a space.
Mm-hmm.
Okay.
Okay. All right, so hopefully you're in your data course now. We're going to open up a new script, Control O. And I'm going to go to code examples. All right, code examples and data course my last name. And I'm going to scroll down to ggplotintro.r. All right, put your little cartoon hand up when you've got ggplotintro.r opened up and you are in your R project.
Dr. Zahn, to double check, to change my position from desktop to data course, my last name, it's just set WD and then data course, my last name, right?
No.
No.
Open up the project.
Oh,
Right.
okay.
So file, open project.
Oh, okay. Right. Oh, okay. Okay.
Desktop, data course, your last name, and then double click on this, the .rproj. All right. The shorthand way is if you don't have a bunch of projects going all the time, up here in the top right,
Mm-hmm.
you can click on that and it'll give you a list of your last 10 projects you've worked in. And so it's kind of just like a little shortcut. You can go to data courses on.
Oh, okay. Thank you.
Mm-hmm. All right, so once I'm in my project, then I just do Control O, code examples, ggplot intro, done. Okay. All right, those of you still trying to get this open, let me know what the problem is. Where are you? Where are you getting hung up?
I'm just opening it up right now.
Okay.
I can't find the GG plot to, or I can't find where we're supposed to open it up.
All right, Control O. It is in code examples, ggplot intro. All right, there's still a few of you that don't have your hands raised. They're down to 2, down to 1. All right, talk to me, Ethan.
Yeah, I still can't find it in mine. I just have the folders. I don't have all those files. So I might just have to do a git pull.
Do you, so you're in data course Struce, right? And you have code examples?
Yep.
And when you double click it, nothing comes up?
Well, I have example day 1, example project, ggplot2 tutorial, R intro, SRA tools, and vegan _ example.
But none of the actual files?
I don't have any of the actual files.
Okay, real quick, open up your terminal. Go to my data course, so just data course. So it'll be desktop. You won't have Git repositories, but you'll have data course. Right?
Yeah.
Okay. So in there, do CD code examples. Look around. Do you have a bunch of stuff?
Give me just a second. Okay, it looks like, yeah, I just need to pull them over.
All right, so what you're going to do is go back up to my data course. So you're in desktop data course. Say CP space -R code examples. That's going to copy recursively and then send it back one into data course. Like that.
Perfect. I'll go ahead and do that real quick.
Yep. Run that and you'll be good to go.
Don't forget it's all caps.
Oh, right. All right, so that'll copy the whole code examples folder from my folder to your personal directory. All right. So then you'll have all this, and then just go in and open up ggplot intro. Okay. So ggplot stands for the grammar of graphics. We're going to spend a week and a half, maybe 2 weeks, basically playing with this plotting feature, because when we're doing data analysis for anything, whether it's sociology, biology, financial stuff, whatever, data science has basically kind of the same life cycle. Okay, we read in our data, we clean it up, then we visualize it, and then we model it, and then we present it. Okay. In reality, this kind of is a vicious circle. We're constantly adjusting things before we present it, but you got to stop at some point. Most important thing, though, is that to understand our data, we really should be visualizing it. Humans are pretty visual. Okay. So first thing we do, we're going to be doing this an awful lot in most of our scripts, is library tidyverse. All right, so I'm going to run that line 4 there. Okay, that loads the tidyverse, and you'll notice that one of the things it loaded was a package called ggplot2. Okay. And then we're going to bring in some data. Data Midwest package ggplot2. So this data set comes with the ggplot package. You can see we've got it as a little promise up here in our environment. Okay. Now, ggplot's a bit confusing at the beginning, but I promise you'll get the feel for it, and you'll see how powerful it is. Essentially, we're going to be building plots from the ground up, one layer at a time. Okay. So the layers start out, the first layer that you give it is some data to work with. So you're saying, hey, ggplot, here's the data we're going to be playing with. Okay. And then you tell ggplot what aesthetics you want to use, right? Do you want some of that data to go to the y-axis? Do you want it to go to the x-axis? Do you want some of that data to inform the coloration of your plot? Maybe the shape of the points, okay? Maybe the fill of your columns that you're making, all right? So we give it some aesthetic properties, and we map that to our data. Then we actually do the drawing, and we call that geometry or a geom. Okay, so that's where we actually draw the layers. Okay, then we can play around. So let's build a plot from the ground up, just all together. Let's do this here. So starting at line 27, this is the basic syntax right there. ggplot Midwest. We just gave it a data frame. ggplot definitely wants a data frame. Okay, so I'm going to run that. What did you get in your lower right quadrant? Hopefully, it looks like mine, a big blank space. Anyone else see that?
Yeah.
Okay.
Yep.
Cool. So it made us a plot. It did its job. What do you think of that plot?
I don't think it's telling us much.
No, it's not telling us much, but ggplot knows about Midwest, and it said, here's your plot. Because we didn't tell it anything about x-axis, y-axis. We didn't tell it anything about colors or transparency or shape or fill values, nothing. We just said, here's your data frame, okay? So here's how you tell it about aesthetics. We're going to just basically take this previous command and say, hey, ggplot Midwest, comma, here's the aesthetics I want you to care about. Okay. Here's a list of the possible things we can tell ggplot to care about. It's all our column names. All right, so if I click up here in the top right, we can see we've got PID, county, state, area, pop total, pop density, pop white, black, American Indian, Asian. Okay. So we got a bunch of different columns in here, all these different variables. We can tell ggplot to pay attention to any of them and to map them onto certain aspects of our plot that we call aesthetics. So this is the command, AES. And we're saying, here are the aesthetics that I want you to care about in the Midwest dataset. I want you to pay attention to an x-axis, and for that, I want you to put area. There it is. That's one of our columns. I want you to have a y-axis that you pay attention to, and for that, I want you to put pop total right there.
Why don't we have to do like X label and Y label for this?
Because it is smarter than the built-in plotting.
Cool.
Yeah. So I hit Control Enter on that, and presto, we get a plot. What do you think of this one? What new info is it showing us?
Doesn't have anything in it.
Well, it's actually got a little something. Sort of. I mean, we didn't draw any actual data.
The X and Y axis.
X, Y axis, and you'll notice that they already have a scale. So it has gone in and looked at the column called area and the column called pop total, and it chose an appropriate scale for them based on that. Okay. So we've got, it's here in scientific notation, but it goes from 0 to 5 million for our pop total, and then area from 0 to 0.1-ish, or 0.12 or something. Okay. So it's gone and chosen appropriate or reasonable scales. We can change those later if we want, but it's done that. Okay. So it's given us a blank plot. It knows about area and it knows about pop total, but we haven't told it to draw anything. So that's where we add this. So remember, we need to give it a data frame, we need to give it some aesthetics, and then we need to tell it a geometry to draw. So all of those geometries start with geom. Okay, so they're real easy to figure out. So here, we've basically taken this entire line, copy pasted it right there, and then just said plus. Okay, so this plus is just saying add another layer to our base plot. And the layer we want to add is something called geom point. I hit Control Enter there, and bingo, we got ourselves an actual plot. Okay. Is any of this making sense so far? I see, Ernie, you got your hand up.
Oh, sorry. I just had it from last time.
Oh, sorry.
So for AES, is that always just going to be the X and Y axis that we're throwing in there?
Oh, there's lots of stuff we can do. We're about to see some more, but X and Y, not every plot has an X and a Y, but most do. And so for the most part, you're going to want to give it a column to use for the X and a column to use for the Y. Other things like point shape, point size, color, transparency, all of those can be mapped to aesthetics. Right. So here, the next little line here on my line 46, we've done the same plot with our geom point, but we've added a second layer. Scroll over so it's a bit easier to see. We said, okay, add this geom point layer and add this layer called geom smooth with method LM. What does that do?
It's a smooth line, and I'm guessing that the method tells it what the line represents.
The method tells it the math to use for the line. In this case, LM stands for linear model. So we told the line to be straight.
So is that a regression analysis of the data?
Already, you just didn't. That's a regression analysis right there. It's done. Yep.
So is that a best fit line or?
Yeah. It's a linear regression of the effect of area on population total.
How do we get the equation out of it?
We actually just have to run that model ourselves. It's pretty simple. I want to save that for later in the semester, though.
All right.
But yeah, it's real easy. Okay. So this is just the visual representation. R went ahead and ran a regression model for you. It knows about the equation. It's buried deep within your plot if you wanted to pull it out, or we could just easily rerun it and find it ourselves. Okay. So I want to show you that you can actually store these plots also. Often you'll see this as just P, or like P1, P2, P3 for your different plots, because that's easy to write. But you'll see that this is basically the exact same plot we just ran. We're just sending it over to an object called P, and it pops up in our global environment. I look at that. It says it's a list of 9 items. The first item is the actual data. Okay. So it came from a data frame, and it's now called a tibble. That's just a fancy data frame that's easier to print that Tidyverse likes. Okay. So it's basically still a data frame, and it's got all of our data in it. Okay. And then we've got some layers. We've got a list of parameters that were fitted to our aesthetics. We've got a function that computed the aesthetics. We've got a function that created our geom1, which was our points, and our geom2, which was our line. So we could actually pull this out, the equation for it, out of our plot. Okay. Got all these different parameters here, and it's going to run out of room. Yeah, 65 lines emitted. So this plot is a complicated R object in and of itself. But if you want to see it, you can just, not capital P, lowercase p, you can just hit Control Enter on that, and it'll plot it for you automatically. Okay. So this is how you start composing a more complicated plot, starting with the basics. Like we can say, hey, here's the X and Y I want you to care about. Put some points, put a regression line, and then save that as P. So now we can play with that by just saying P plus. All right, so we're going to add a new layer. In this case, we're saying limbs. X is a 2-element vector, 0 and 0.1, and Y is 0 and 1 million. I hit Enter, Control Enter, and what does that do?
So that just changed your axes labels, right? The min and max. But the X max and Y max?
Yeah, so we give it a minimum X value, maximum X value, minimum Y value, maximum Y value. Okay. So you can see that we basically shrunk our data down. So this, we just add a limbs argument to our plot, and it will remove all points that fall outside of those min and max values for X and Y. Okay. What about this one? P plus coord Cartesian, X lim is that, Y lim is that. Looks pretty much exactly the same. How is it different? I'm going to just go back and forth between these two plots. You can do the same thing with these little arrows here.
I have a guess.
Okay.
So the first graph, I think just the graphics that we see are the 0 to 1 million. But in the second graph, does it just delete everything outside of the 0 to 1 million? As in, In the first graph, the data is still there.
You've actually got it the other way around.
It's the other way around. Okay.
The limbs actually will delete the data that you tell it to not pay attention to. So limbs actually deleted all data points that were bigger than 0.1 for X or bigger than 1,000,000 for Y. The coord Cartesian is just changing what we see. Okay. So
Gotcha.
coord Cartesian is basically zooming in without changing the data. Limbs is chopping out all the data except for the little box that we want to view. And that changed our regression line. So here's the limbs version. Our regression line looks flat. Here's the coord Cartesian version. This is actually the more realistic regression line. If you go back to our original plot, you can see that it's actually kind of going up here. It doesn't look like much, but it is. Okay. So I want to show you that to show you that you can just take your plot that you've built, P, and kind of zoom in. So keep in mind the coord Cartesian and the limbs function. Okay. I'm going to go with coord Cartesian because we're not actually changing the data. We're just zooming in closer on part of it. And I'm going to call that P2. So P2 is now being stored as P plus our coord Cartesian. Ta-da! All right, so over here we've got P2 now. It's a little list of 9. Okay. What do you think this does? Line 60 on my screen.
It's going to add a title.
And some labels. You can tell that because I've been a good boy and I've actually added nice comments to my code here. You should be doing that for your code as well. So get in the habit. Say what you're about to do and then do it. All right, so P2 plus, if you want to add labels to any part of your plot, you just add the labs layer. So we're just stacking another layer on top of our P2 plot. So here's P2. It's this plot right here. Okay. P2 plus a new layer. We've got labs, title, subtitle, Y, X, and caption. Okay. I'm gonna zoom in on this.
Well, what would happen if you tried to add 2 together that have conflicting features? Would the second one override the first one or something?
Yep. Whatever came latest will be plotted on top. Yep. So we really are building a plot like layer after layer. And so anything that comes after will be plotted on top. All right, so we've got our title up here, our subtitle, our Y, population, X area. Basically, I just wanted those to be capitalized so they look nicer. Okay. And then we had a caption, and that pops up down here. So this is Midwest demographics. All right, so already this is starting to look like a chart that you would see on like 538 or a reputable news outlet. Okay, we've got good labels. We've got numbers on our axes. Okay, looks good.
Question.
Yes.
So we used title to throw a title on there. Could you use main as well? Is that just the same thing?
Nope. As a matter of fact, if you want to see what different things you can label, you can do labs and then hit tab. You've got title, subtitle, caption, tag. So a tag label displayed at the top left of the plot. So like if you see in some journal articles, they'll have like 4 plots next to each other, A, B, C, and D. So the caption can refer to all 4. So you can tag it that way. And then anything that you have an aesthetic for, you can add a label to. So we had a Y and an X. So in our aesthetic way back up here, So because we had a y and x, we can label y and x there. All right, so all together, this right here is the full code for that plot. I'm going to walk through it. I'm going to go as slow as I feel like, but please stop me if you need me to explain another line. I'm going to try to explain this in plain language. So we have a call to ggplot function. We tell it a data frame that we have up here in our environment. Okay. Then we say, comma, here are the aesthetics I want you to care about. We gave it an x-axis and then the name of a column in our data set, a y-axis, and then the name of a column in our data set. Then we said plus, so new layer, geom point. That just draws the points on there. Okay. It calculates where those points go based on the fact that we told it to pay attention to area and pop total. So it does that automatically. Then we said plus, meaning new layer. On top of our points, we want a smooth line. Okay. Smooth line is going to look for x and y, and it's going to run a regression model on them and draw a best fit line. Okay. It already knows about our x and y because we gave that to the main ggplot function. So this x and y apply to all the geoms downstream if we want them to. Okay. And then we said, hey, I want you to change this a little bit. I want you to use a linear model for your method. Okay. Then plus, new layer. This is a transforming layer. We're going to transform the actual look of our plot using the coord Cartesian. We're going to say just zoom in. Here's our x limits, the minimum and the maximum. Here's our y limits, the minimum and the maximum. Zoom in without changing the actual data. Okay. And then plus, new layer, we're going to add some labels. The labels we want to add are a title. Here's a character string for what I want that to be. Comma, a subtitle, a Y label, an X label, and a caption. These can run over onto new lines, no problem. And it even automatically indents for us. So this will still run because this ends in a comma, whoops, right there. It's saying, hey, keep on waiting, I'm not done with this labs function. All right, so there's our plot. We built it kind of from the ground up. Any questions about this?
Yeah, are there help files? Oh, sorry.
Yes, there are. Like any good function in R, we've got ggplot help file. Okay. This may not be as useful as you want it to, but it does give you some good examples. Better yet, though, your trusty instructor has gone through and curated a list of nice ggplot tutorials. Okay, how to plot anything in ggplot, part 1 and 2, nice little videos. And then this cool little tutorial where they take a ggplot and start with a very basic one, like here's an x and y, and here's the data, and then just progressively build on that. Okay, so go through these, take a look at them, but we're going to get practice in here. Don't worry. Okay. Okay. We can make this pretty. We can change anything we want about our plot. So we can change the colors that are used. We can change what type of line is drawn, whether it's a dashed line, right? All that kind of stuff. So let's look at this plot here. If I just highlight this and run it, looking at my code, let's see if we can make sense of how this looks different from the previous one. What did I change between these two?
Colors.
That's it. And look where I did it. I also changed the size, actually. I forgot. So I went from smaller dots to larger dots. Okay. So within any of my geoms, there's a bunch of things I can change about them. Okay. In geom point, I can change the color, and the R has some built-in color names, or we can set our own with like the hexadecimal colors. We'll get to that in a second. I can change the size. I can change the shape. So I could say shape equals 5. I don't know what that is, but we're about to find out. Hey, there it is. Hollow diamonds. I kind of hate that. So Control Z, rerun. Okay. So up here, our geom point was empty, right? So we're just going with the default on everything. Here, we're saying, all right, pay attention to a couple extra things. I want you to change your default behavior, your color, and your size. So let's take a look at that. Question mark geom point. Mapping, data, stat, position, inherits. This gets pretty confusing, but down here, it says geom point understands the following aesthetics. Required aesthetics are in bold. The only ones required are X and Y. It also understands alpha, color, spelled the American or British way, okay. Fill, group, shape, size, and stroke. So those are all things that we can change about our points. All right. What about smooth? Question mark, geom, smooth.
Quick question.
Yeah.
Is there, when you do the help file for ggplot, does it list all the different geom options?
Luckily, they all start with the word geom. So I can just type in geom underscore, and it's going to give me, look at all these.
Okay.
There is a buttload of them. To start with, we're probably going to just be picking a few, but it will let you make really nice, complicated plots. Okay, so there is a lot to pick from. The most important ones that we'll do at the beginning of this class are geom point and geom smooth, because that's essentially like statistics right there. Okay, but there's all kinds of stuff, and we'll see a few extras today. So yeah, just typing in geom underscore and then tab will give you all these nice options, and it kind of brings up what it does, right? So geom bin 2D divides the plane into rectangles, counts the number of cases, and then maps the number of cases to the rectangle's fill. Interesting. Okay. So I've told geom point, make the size 3, make the color steel blue. I've told geom smooth, it requires an X and a Y, but it can understand alpha, color, fill, group, line type, size, weight, Y max, and Y min. Okay. I'm just telling it color. Fire brick. I like that color, sure. So I run all this, and yeah, we get slightly larger points. They're blue, and then our line that we drew is red. Okay. So let's save that as P3. So if we type in P3, what happened?
Wait.
I changed something here, and I put it in the comment for you. See if you can figure out what's going on.
Yes, you've made a lot of colors here.
How?
The geom point has a static specifications.
Aha, that's exactly it. All right, so previously, I just told geom point, hey, here's the color you're going to be. Now I'm telling it, hey, I want you to look inside the data frame and find a column called state. and set the colors based on that column. That's because I wrapped it inside of aesthetic. So pay close attention to this difference. Up here, I just gave it the name of a color, and all the points are going to be that color, that steel blue. Down here, I said, I want you to map the column called state to an aesthetic called color inside geom point. So this gets weird. But what actually happened there? This is really nice behavior for ggplot.
It's color coded.
It's color coded, and it built a little legend for us automatically. Isn't that neat? I love it. I love it so much. So if you want to color points by a column in your data, it's really that easy. Okay.
All right.
I have a
Just needs to be
Go,
an
Ernie.
aesthetic. If you give it a color without being an aesthetic, it'll make everything the same color. If you give it a column name as an aesthetic, it'll color by that column name. Okay, question.
For the method in Geom Smooth, how do we know what to use in there instead of
Question mark geom smooth. Let's look down here. Method. Okay. It can be any function that makes a line. It can be LM, GLM, GAM, LOS, or you could write your own function or use one from another package.
Right.
So any statistical function that you want that takes an X and a Y, you could write that in and use it. By default, it does LOS. Let's take a look at that. I'm going to take P3 here and just delete the entire method section. I'm going to save that and run P3 again. Check out that.
Whoa.
That's a smoothing function called LOS. LOS is really nice for looking at relationships between data like X and Y, but LOS, by its nature, does not actually have an equation. It's a moving average, and so there is no true equation for it. So if you're trying to do stats or look for like a linear regression, LOS is not the way, but that's all right. It's still a fine default because you really get to kind of see a moving average of your data. I'm going to do Control Z now to put method LM back in, so we're all working with the same thing. Run P3 again, and you can see we forced it to do a straight line.
Cool.
But I really despise the default colors for ggplot. They're very hot pink heavy. I think that's really hard on my eyes. I hate it. And if you're colorblind, these aren't actually a good option. So let's try P3 and add a new layer. Scale color brewer palette equals set 1. Huh. So R actually has a bunch of built-in palettes. Okay, we don't have to use the default colors. See if this line works for you. Library R color brewer. I don't know if R 4.0 comes with this pre-installed or not, so tell me if you get an error or if it works.
It worked.
It worked? Right out of the bag, huh? Cool. All right, so you've got that built in. You can always say library R color brewer and then run this command, brewer.pal.info, and it's going to give you the names of a bunch of palettes that you can pick. You see that I chose set 1, okay? It's got 9 colors. It's for qualitative data, and it is not colorblind friendly. Okay.
Oh, cool.
So let's change this. Pick one of these. Which one do you want me to do?
Do dark 2.
Dark 2. All right. Dark 2. Neat. All right. There's a package I like to use called Color Blinder. Because guess what? I don't know if you're aware of this, but there are some colorblind people in the world. More than you think. If they can't read your plot, you're not communicating your science to them. So the Color Blinder package lets us look at our plots as if we were colorblind. If you run this, it's going to give you an error because you don't have it installed yet. All right. So I want you to go here. Where was it? So it's in week 4. The Color Blinder package. It's not as easy as saying install packages Color Blinder. This one is not on CRAN. And so you actually have to do these 3 lines of code in R. All right. So I'm going to copy them. I'll stick them in the in our little chat. All right, so they're in our chat box. If you're having trouble finding this Color Blinder package, it's right here. Copy those in and paste them right into R. So in order to run Color Blinder, this is a really neat package. I definitely think that you should be using it. Just run these one at a time. Raise your cartoon hand when you've got them. If it asks you to update stuff, it says, hey, there's more recent available. Would you like to update? Just say, click down here and hit enter. No, forget it. So it'll install this package called cowplot, and then the color space package, and then and only then can you install Color Blinder. And this lets you install straight from GitHub without having to worry about CRAN. All right, so those 3 lines should get it for you. Looks like Ernie's got his.
Wait, no.
No, Emily's got hers.
Okay, I think mine's coming up with an error when I try the first remotes
Me
install.
Yeah, mine as well.
Cowplot, it just says
You're gonna
there's
error
a
there.
package called remotes.
Okay, no package called remotes. That's easy to fix. I'm gonna go over here to packages, install remotes, and make sure install dependencies is checked, and then go ahead and click install there. Then you can run the 3 lines. It's always something. So while we're waiting, I'll probably, it would behoove me to explain what's happening here. The double colon next to the word remotes here, that's saying from the package remotes, use the function install GitHub. And so when you install the package remotes, it gives you this install GitHub function. So that's what this double colon is about. We're saying there's a function called install GitHub. You don't know about it, R, but it is to be found here in remotes. And so that's why you were getting an error, because R was like, Yeah, you telling me this, but I actually don't even know about remotes.
So if you get an update notification, then you click 3, or?
I did none. So I clicked down in here in my console, so I got my little blinky cursor, and I just hit enter for none. Empty line to skip updates. You should be good. Like you've all got brand new versions of R. There's no need to be updating yet.
Done.
Cool.
Okay, I have a little note that popped up. It says updating loaded packages. And it says one or more of the packages that will be updated by this installation are currently loaded. Then
That's fine.
Restarting R prior to updating these packages is strongly recommended. If I do that, it's going to delete everything that I've done.
Don't worry about restarting R for that. It's okay. Yeah.
Great.
Sorry, I missed the part where you were showing how to load the remotes.
Oh, it's just like when you install Tidyverse, go over here to install. Like, make sure that you're on packages.
Yeah.
Install, and then just remotes, and then install. All right. While we're waiting for people to get Colorblinder installed, I've made my own little palette here. How did I come up with these wacky numbers? These are hexadecimal values.
Yeah.
Well, let me show you. I went to Google and I said color picker. Neat. All right, so you get to slide it around, find colors that you like, and then boom, there's your hex value for that color. All right, so I went through and picked some colors that I thought were kind of a fun color scheme for me. They definitely avoid hot pink or like light yellow, which you can't see on a white background. And I just picked a bunch and I stuck them together in a vector. Okay. So feel free to choose your own colors in this way. I'm just calling this PAL for palette. If I look at it, it is just a vector of these hex values. Okay. And the color blinder package, once you get that loaded, gives you a function called palette plot. So you can just see all of the colors that you've got. Okay. Now, what's really nice, and this is the main function of the color blinder package, is this function called CVD grid. You can feed it any plot you want. So I'm going to feed it my palette plot and take a look at it. This is what my color scheme looks like to people with different versions of color blindness.
Wow.
Yeah. So you can imagine that maybe a plot wouldn't be so great. Let's see, we had that really ugly one we made. I think it was P3, right? Yeah. I don't like the pink. So let's try this CVD grid for just P3. All right, since we have that plot saved, take a look at it. Taking my computer a little bit of time here. Okay. Okay, so if you had full color blindness with desaturation, you get nothing from this plot. There was no point to adding color to it. Okay. What about if you had trig anomaly? This is a less common form of color blindness, but Illinois and Wisconsin look essentially the same here. Prot anomaly and dude anomaly. You can see that this doesn't quite work super well, so you might want to pick a color scheme that is colorblind friendly. Or better yet, let's see here. P3 plus, let's add a new layer. P3 plus plus. If I wanted to change the point shapes in P3, what could I do? I don't want them to all be little circles. Because colorblind or not, you can tell the difference between a square, triangle, cross, whatever.
The geom point, or
in geom point, I can do something.
A method?
Not method.
Shape equals, and then some value.
Shape, because here's geom point. It understands these aesthetics. So one of them I could say shape. Where do I put that in my geom point? Inside an aesthetic or outside an aesthetic?
You're going to want to put that inside.
Inside, because I want the shape to vary based on state. And so here, I'm inside of my aesthetic. Okay, I've got color equals state. I can just do comma, shape equals state also. So let's try that. P3, rebuild that plot, and then look at it. Hey, all right. So now when I come down here to my CVD grid, I've got these 5 different shapes. Even if you are colorblind, you're still going to be able to tell the different states apart from each other. More or less. Okay. Okay.
Wow.
All right. I'm going to add my custom palette here. Remember, it looks like this. Let's just pretend that I just really love these colors, or maybe it's a style guide that my job wants me to follow. Right, so like the Washington Post has their own style guide, okay? Business Insider has their own. Let's just say that UVU actually does too. They want these different types of UVU approved greens and blacks, okay? So I could make my palette, and then I can take P3 and say scale color manual, and say, hey, the values, the manual values I want you to use are my PAL. So there it is. Okay. So this has just been one short class period, but I think you're ready to start building plots from a data frame already. You're going to be following this exact same recipe at the beginning. Okay, as you get better and better, you can break out of the recipe. If you want something to vary based on one of the columns in your data, you put it in an aesthetic. If you want something to be the same throughout your entire plot, you put it outside of an aesthetic. So here, we've got aesthetic, and we said, I want that to vary. I want color to vary based on state, and shape to vary based on state. And then outside of the aesthetic, I said, I want the size to be 3 for every point. Okay. So let's take a look real quick. Let's run through some of these and see what we can do. Scale X reverse. Okay. Theme minimal. Theme dark. This is real ugly. It looks like an Excel plot. Okay. Here, I can actually transform. I'm showing you, you don't have to give it a column name. You can give it a transformation of a column name. So X equals area divided by the maximum of area. So what have I done there? That's just a proportion of the maximum. So rather than just raw area, I'm saying I want my X aesthetic to be area divided by the max area. So proportion. Here I can say I want my Y to be log 10 of my population total. So I'm doing mathematical calculations within my ggplot. Real pretty. Let's see here. Okay. So already we're getting a more meaningful plot here. We're looking at how area is related to the log of population. We've transformed some of our data. We've given it a smooth line. We've added labels. We've said minimal background stuff so it's easier to read. And then we've said use a manual color scheme based on my palette that I made earlier. Okay. So in the last like few minutes that we've got here, I want you to go through the rest of this script and kind of see what's going on. See if you can figure out what's happening, okay? And definitely hit up these resources, okay? I want you to look at the ggplot tutorials and this evolution of the ggplot. You can really see how a graph gets built layer by layer, gets transformed, okay? Because we've got a fun assignment coming up. This one is not for points. It's for fortune and glory. It is the ugly plot contest. Okay. You have to be pretty good at plotting in order to break all these rules. So this will be due like end of next week or even beginning of the week after. Okay. Take a look at this site for what makes a good graph. I've got a nice little list of things that go into making a good graph. And then you got some example plots from previous semesters. So that plot sucks in every possible way. I hate it. Look at the color scheme on this one. Okay. That's fun. All right, so we're going for really bad plots. This is hardcore. Instead of points, they like loaded up a bunch of image files and had ggplot use those as its points, and then change the background to be this screaming hedgehog. Okay, so there's a lot we can do with ggplot. It's really customizable. We can even do animated graphs. Okay, and as we move into our next lessons, we're going to see all these customizing options. All right, so I want you to be familiar with the basics of laying out a foundation of a plot. Okay, so by next class period, be ready to add aesthetics, throw in some points, throw in a trend line, maybe change the labels. Okay, because then we're going to get weird with things. We're going to see how to change the background, how to change transparency based on something in your data. These are just awful plots. So I'm hoping to get some really ugly ones from you. Okay. So that's what we're working for, is making a really bad plot, and it's harder than you think. Okay. But just to wrap up in our last minute, I'm going to run through some of these and show you like kind of the power of ggplot. Real simple code, and we've got already a really nice looking area versus population on a state-by-state basis. And you can see how some, Wisconsin, there's no strong relationship, but Illinois, there is. Okay, we're learning things about our data in a really quick way. Okay, so look through these examples, see how I've changed things between the two different lines, and that'll give you kind of a starting point to use the same kind of code, just translating for whatever data set you're working with. Okay. Any questions? We will have plenty of time to practice ggplots, but I want you to be at this point by next class period, being able to basically compose this from scratch. Okay. See a couple hands. Oh. Accident hand. Sorry. Steven, you got yours raised? No. Maybe.
No, ignore that.
Okay.
Okay, I do have a question.
Great.
Back where it is like the palette underscore plot and then pal, where you made your own stuff. If I run that line, just that simple little one, it gives me an error that says could not find function palette underscore plot.
That means that you didn't load the color blinder library.
Okay, that's what I was wondering. Everything up until that point said it worked. It said done, but maybe.
All right. What happens when you say library color blinder?
Oh, yep, you're right. It does say error.
Not found. Okay, so go through these 3 lines again. Make sure that you've got the color blinder library. Once you do, and run that line there, then you'll be able to do palette plot.
Okay.
So the palette plot is just not built into R. You have to have the color blinder library. And of course, the color blinder library is kind of difficult to install. It takes these 3 lines. Okay. And
so those 3 lines all
on
separately.
remotes.
Oh wait, sorry, say that again.
They depend on remotes. So if you don't have the remotes package, you'll have to do install packages remotes also.
Earlier. Okay, I'll try all those and see what I can do.
Yeah. So those 4 lines should work and enable you to run color blinder.
Does anything bad happen if you install multiple times?
Nope. Nope, totally fine. I mean, you waste some of your time, maybe 3 minutes sitting there waiting for it, but that's all. I bring this up, this color blinder, because a lot of people don't get this training. People that are really good at ggplot still just don't even think about the fact that 10% of the population can't actually read their chart. Okay, so I wanted to get this out of the way right now, making sure that our plots are accessible. It's just something to think about. And also, you get to use a package that's not on CRAN. There are a lot of R packages that live on somebody's GitHub repository, and this is how you install them. So this gives you a nice little rundown of that also. Okay. So definitely be at the point where you can compose this plot from the ground up, changing the colors, adding labels, maybe doing some mutations of the data within it, right? So we don't have to just say x equals area as an aesthetic. We can say x equals area times 10 if we wanted to lie with our statistics, right? Okay. So be ready for that, and then we're going to start talking about what makes a good plot and learning tricks how to change things. Okay. Alrighty. Somebody was going to stay after for...
That's me.
Okay, great. Well, here I am. What can I help you with?
Well, Lacey, did you want to stay after as well to talk about the research stuff?
I'm here too.
Okay.
So we'll start with the research stuff if that's okay, and then we'll go into my question about R. So we've been out twice looking for mushrooms now.
With no luck?
No luck. We even found those specific, we went to the coordinates that were given to us and found those specific trees.
It was like way dry, so I don't think that there was much of a chance of mushrooms there.
What about after this rain yesterday?
That's a good question.
Do they pop up that quick? I mean, I don't know.
Yeah.
Yeah, they do. They pop up in the next week, like over the next week.
Huh.
So that might be worth, it might be worth going back to those places if it's not like too out of your way. Because after the rain, I mean, that's what they're waiting for. If they're not there, then in 2 weeks they will be. It's kind of that situation is we're almost at fall. Yeah.
So the prime mushroom hunting time is fall?
Yeah.
Okay.
Yeah. Onset of winter, increased moisture, that does it for them.
Okay, that's good to know.
Let me stop recording because our class doesn't need any of this. Okay.